Today we are going to learn about current to voltage converter and vice versa, voltage to current converter. First, we are going to learn about current to voltage converter. The circuit is very simple. So first, we take an op amp. So I have taken an op amp. This is negative, this is positive. Positive is grounded. This is R, this is V0, and in this particular place I am going to take the current, I in current. So since output is connected to the negative terminal, it means there is a negative feedback. Virtual ground exists. My Vp is equal to 0 because this terminal is grounded, positive. So applying KCL at node Vn. So at this node Vn, what we are going to have? In equal to Vn minus V0 upon R. So my Vn is 0, then Vp equal to 0, so my Vn equal to 0. So In equal to minus V out by R, which corresponds to V out equal to minus R into In. So if we see this particular equation, what we are going to have? We are going to have that my output voltage is proportional to the input voltage. So I have converted my input voltage into the input current to the output voltages, and that's why this particular circuit is known as current to voltage converter. Now we are coming to the reverse of it. So this is voltage to current converter. Voltage to current converter. So this is also known as VI, V to I conversion. So for this, what we are going to have again? We are going to have op amp. So this time you have to see carefully. So this is op amp. This is my R. See, you have seen this particular diagram many times. So let's say R, and this I am going to place R at load resistance. V out. At positive, I am applying voltage V in. So you can have AC voltage, DC voltage, doesn't matter. So again, we are going to apply the op amp concept. So first we are seeing that my RL resistance is between negative terminal to the output. So op amp is in negative feedback. So my Vp is equal to Vn. From here, now Vin, apply KCL at Pn. This is what we are doing normally, but this time we are not going to do this one. So what we are going to do this time? So my Vn equal to Vp equal to Vn as usual. So Vn is available here. So I am going to mark current direction like this. So what will happen? And this current value is I1. So I can write I1 equal to Vn by R. So V in by R. So my current depends upon the input voltage. My current depends upon the input voltage because I1 is proportional to the V. Similarly, now at node Vn, I can write So next current I am going to consider like this IF. So I can write IF equal to I1. So when I am going to write IF equal to I1, it means that this feedback current, which is sometimes also known as load current, IN. So first we write IF equal to I1, and then subsequently I can write IL equal to I1 because IL is the load current. And this current is equal to feedback current. So what we are going to have? IL equal to I1, and this is equal to V in upon R. See it carefully. What it says that? It says that load current, which is the output current, that depends upon the input voltage and some resistance R1. So my output current doesn't depend upon the RL. So output current does not depend on RL. It doesn't depend upon these feedback resistances. So this particular circuit is voltage to current converter. And this particular practical application is this. So we can use this particular circuit to make the measuring device. We are measuring the current coming from the voltage source. So we are going to have a voltage source here, and in the place of RL we are having the ammeter. So the diagram, so for application, so you can see like this. So this is the op amp, this is my R, which will decide the value of current. This is my V in, voltage, minus sign, plus sign. This is my output. So output is not. Now from here what we are going to have? We can have a ammeter. Ammeter. So this ammeter will measure the current. So directly how much current is coming from the source, we can measure it. So for this voltage to current converter is used. So I hope you have understood the working of voltage to current converter and current to voltage converter. Thank you.